Welcome back to our presentation for Sprint 3. This is Joseph Annunziata from Team High Five regarding our app SignIt. Just wanted to get started with Deliverable 3. We have a lot of items on the agenda to cover today. I'm briefly going to introduce the team and our roles again. Improvements made from the professor, the project description, teamwork agreement, and personas, as well as the minimal viable product for our application. Shijo will cover technology, algorithms, and diagrams. I'll come back for the Sprint 2 recap, and Fariel will handle the product backlog as well as Sprint 3 backlog. And I will return for the metrics and summary of the retrospective, as well as the Sprint 4 backlog and the project demo. Our team, I'm Joseph Annunziata, the Scrum Master and Machine Learning Engineer. Farial Alam is the UI developer and testing engineer. Renee Irias is the full stack developer and UI engineer. And Shijo is a backend developer and machine learning engineer. There were a number of improvements made from Professor Wong's feedback. Some of them include the teamwork agreement. We made a couple changes to that, as well as changes to the user stories and the formatting of those in the product backlog. We made changes to the completed and committed stories as well. We corrected the acceptance criteria format and their correlations with the user stories with a key related directly back to the user stories. We did the same for the test cases as well. We made changes to the team velocity and burn down charts according to what Professor Wong had requested, as well as we made changes to the ratios and the Sprint 4 format, as well as the demo format. Reiterating our problem statement, deafness and hearing impairments are difficult experiences to live with. A lot of people are socially marginalized. It's hard to get jobs. It's hard to live in a society that doesn't understand sign language. So that is a big problem in society today. Our project description. For those who have limited or no knowledge of sign language, our application is an analytical mobile application that recognizes and translates sign language into English. Unlike other apps designed for the deaf community that generally only focus on educational purposes, such as videos and some lessons, our application actually does a live translation and a live analysis and recognition of signed words in order to bridge the communication gap. One of the items that we improved on was the teamwork agreement. I had added, according to the professor's feedback, about the retrospective that is mandatory attendance for retrospective meetings, as well as discussing implementing a topic that we discussed in our weekly meetings and retrospective of keeping weekly meetings to one meeting a week, and we felt that it was more productive that way, especially towards the end of this project. Persona 1, Jane is a mother of a child who is deaf, and she's trying to learn how to communicate with her daughter. Simon is a project manager who is basically entrusted to integrate Paul, who is deaf as well. And in order to bridge that communication gap, Simon is looking for an application, a mobile application that he can use easily to translate sign language so that the team can communicate with Paul. And Persona 3 is Jack, an educator who teaches children and needs to be able to converse in sign language and be able to utilize an application to help teach sign language to students. Our minimal viable product consists of a login page with a field to enter email, password, and an alternative Google sign-in button, as well as a button to register a new profile. The registration page, there's a field to enter email, password, and to complete the registration page. And that button will direct you back to the login page to log into the app. The home page is a grid-style dashboard of 4 buttons. There's a button to access the camera, the device's camera, a how-to guide, a button to access settings, as well as a button to log out. The camera feed is a live feed from the mobile device camera that will connect with the machine learning model. And the machine learning model, we actually discussed changing to an alternative model for easier implementation inside Android Studio. So our customized machine learning model is built in a Python notebook with an alternative model called YOLO V5. It's trained on a custom-made data set of 5 different sign language expressions, and is able to distinguish between 2 hands, their positions, and poses very accurately.
So let's talk about technologies. We use Python, TensorFlow, and OpenCV for the model training, and we use Android Studio, Java, and Kotlin for the front-end development. But since this is our second model, what's different from the first model is instead of using media pipe to extract out the key points of a motion or gesture, I use label image, this library, to directly create label from our input image data, and I use YOLO V5, which is the 5th version of YOLO, to help with the model training. So machine learning process is a little bit different. So first, I collect big chunk of data, which is just pure image, for both training and testing. Then I process the data and create labels, use the library I just mentioned is the label image. Then the YOLO needs a like specific requirement for the input data or the training like data images. So I convert all this images and data to fit the YOLO's requirement. Then I split 80% of the data for the training and 20% data of the testing. And thanks for YOLO V5, the model training is a lot easier than before. Then I save the weight of the model, and we also have the confusion matrix for the evaluation and whole other bunch of like charts and stats to demonstrate the training process of the model. Then the model is actually ready to use or test in real time. So as for the conceptual architecture diagram is slightly different from the first one. Of course, the user is going to have open the application first, then open the camera to collect the data from user. And video is just a stream of images, and we take these images and we feed the images to the model, which is trained with the help of YOLO V5, but underneath the hood, it still uses TensorFlow as for the model training. Then the model will just output the feedback like in a real time. This is the conceptual architecture diagram. And as for the sequence diagram, it's the same as the previous version. The user gonna open the application, which is Android application, then the user will see the starting GUI or login screen. After the login, the user just press the button to invoke the camera, and the camera just collecting the images, videos, just and feed this image to the machine learning model. The model just give instance feedback, and which will be displayed on the application screen in real time. Then the user can get real time feedback.
So I just wanted to explain a quick recap on Sprint 2. So in this slide, we actually changed the format of the user stories, which Fariel will showcase coming up next. And basically, we completed 4 user stories, wanting to log into the app via traditional username and password, logging into the app via Google account, accessing a homepage with different features, and keeping the camera open for live translations. And the summary of the tasks that we completed is that we basically did front-end development in Android Studio and integrated the authentication, traditional authentication, as well as Google. authentication. The UI framework for the login page and the home page was also created. And in the back end, we set up the initial machine learning model and trained that model as well. That was the first rendition of the model, which we now have changed.
Hello, my name is Faryal Alam. I'm the UI developer and the testing engineer of our group, and I'll be going over our product backlog, our acceptance criteria, test cases, and some of our user stories and tasks that are completed and some of them which are not completed. So let's start with the product backlog. Over here you can see a table that has all of our user stories. It is divided into the keys, user story keys, our summaries, the status that indicates whether or not they're completed or in progress, or they've not even started yet, and then exactly where you can find them, which is the location. So for example, SignIt 02, as a parent, I want to log into the app via my Google account. This is one of the user stories that has been successfully completed, and you can find it on the login page. SignIt 03 talks about, as a project manager, I want to be able to recover or reset my password if I forget it. This is something that's still in progress, and you can find it again on the login page. Now, something that is not started yet would be SignIt 09. As an educator, I want to be able to adjust sensitivity settings, and that's something that we haven't started yet and which will be available at the camera or the settings feature. Now moving on to our acceptance criteria. So this time in our acceptance criteria, we have added the user story key column so you can relate it back to the user stories. And other than that, it's pretty much the same from last sprint. For example, scenario number 1 talks about accessing the app for sign language translation. For that, we have a set criteria that must be met, which is that the app must offer a sign language translation service that is accurate in real time, which also enables the user to communicate without the need for a paid translator. And the user story keys are here so that you can again relate it back to the user stories and make more sense of the acceptance criteria that we're talking about. Now about the test cases. For this time in our test cases, we have the user story key column added. We have a test case ID. We have a title or the objective of the test case, then test data that we need to perform the steps, and then we'll have the expected result. And instead of having a column with the actual results and whether or not it has passed or failed, and then having an additional column, we decided to go with the column status, which would signify whether or not the test case was passed or failed. So here we have a test case number 1 that talks about the verification of our login with valid credentials. We have our test data. Once entered, we have to follow these steps listed here, such as launch the app on an Android Studio, navigate to the login screen, enter the valid username in the username field, enter the correct password in the password field, and then tap on the sign in button. This we're expecting that the app authenticates the user's credentials and navigates them to the home screen, and that's exactly what happened. That's why we marked it as pass. Similarly, test case number 2 talks about the verification of login with the Google account. The steps are pretty much the same. Instead, we're just accessing it through our Google account credentials, and this test case also passed. Test case number 3, number 4, 5, 6, and 7, they all talk about the testing our machine learning model with our preset or predefined key points that we have. Those would be hello, yes, no, thanks, I love you, and yeah, I think that's it. And for them, what it is that we open our Python notebook containing the model and training the source code. Then we run each cell in sequence in order to generate the model. Then we run each cell in sequence in order to generate the webcam access. And then we perform our desired sign language gesture, and we observe the percentage accuracy. Again, the expected result was that the model outputs the correct label of the gesture data that was submitted, and that's exactly what happened. So we marked those test cases as pass as well. And the percentage that we're talking about would range somewhere between 81 to 100%. That would mark it as that it was recognized perfectly. Any percentage below 41% will not be displayed. That means that the test case wouldn't pass in that case. But that wasn't the matter here. So all of these test cases passed because the sign language was recognized. Again, here we have test case 5, 6. We're talking about the same testing machine learning model with a different label. So as you could see previously, test case 3 and 4 were having the label hello and yes. And then we have test case 5 and 6. The label is different here. We are testing the no label and then the I love you. And then same with test case number 7, we have the key points for thanks label, and then all of these test cases pass the test. Now test case number 8, here we are testing the camera button feed. There are no, or the test data, or the test, the test data is not applicable here because you just need the camera button. Then you navigate to it, you click on the camera button, and the camera button should be working and visible, which is what happened, so we marked it as pass. Then we're having the test case number 9, which is testing the logout functionality. For that, you need valid user credentials such as username and password. You go to the home page, you navigate to the logout button and click on it, and then the user should be able to successfully be logged out, and that's exactly what happened. And then we marked it as pass again. And then lastly, we have our test case number 10, which is testing the profile registration process. For that, you need valid user credentials for registration. You navigate to the first time here sign up label that you can find on our sign in page. And then you click on the register button once you've entered your credentials, and your new profile should be created, which is what happened here, and we marked it as pass again. Now, these are our completed stories and tasks for Sprint 3. Here again, we have the date that it was completed on, and then the keys of the user stories, the summary of what was the user story, and then the status if it's completed or not. Here again, for instance, user story key 06 talks about a project manager who wants to be able to log out of the app, and that is completed successfully. As an educator, I want to be able to customize the machine learning model with my own data sets in a Python notebook, and that is another user story or task that has been completed successfully. Here are our task summary. So we have again the date, the keys, the correlating keys, and then the summary, and then the status that shows if it's completed or not. And then lastly, the stories that are not yet completed are similarly in the same kind of framework. We have the key column, we have the summary column, we have the status column, and the location of where you can find these. So for instance, as an educator, I want to view a history of my translations that would correlate back to the user story 11. And that's not something that has been started yet, and you'll be able to find it in our history page. So this would conclude my part of the presentation. Thank you for your time.
Another improvement that we made based off of Professor Wong's feedback was the team velocity chart. So for Sprint 3, we had committed to 10 user stories, and we accomplished 6 of them. We completed 6 of them. Historically, the user stories from Sprint 2, we had committed to 10 and we had completed 7. And for Sprint 3, we committed to 10 and completed 4. I'm sorry, 6. This is the Sprint 3 burn down chart. The darker blue line is for the planned tasks and user stories. And the lighter blue is the actual completions along with those dates. And this is the historical or the average burn down chart so far for deliverables 2 and 3, starting from February 11th and ending April 5th. And this is the completed to committed ratio for Sprint 3. Committed was 6 stories, completed was 2 stories, so the ratio is 40%. The average for the completion to committed ratio for Sprint 2 and Sprint 3. Sprint 2 is 66.66%, Sprint 3 was 40%, so the average is 53.33%. And historically, we committed to 12 stories and we've completed 6 stories so far. So that historical ratio is 50%. We held our retrospective on Thursday, and what went well for the sprint? We created a new model and trained it as well, and it seems to be a lot easier to integrate than the previous model we had. So that was a really good positive move during this sprint, as well as the communication for that integration and in general amongst our peers. And also the change to a once a week format for our weekly meetings instead of twice a week. We were able to prioritize different tasks that we needed to do, and it was a much easier format for us to do. So, what can be improved? So for this coming sprint for deliverable 4, we will be focusing on integrating the machine learning model within the application, and we've made that our priority task for the sprint, just because it's the fundamental part of our application. Also decision making, maybe picking up the speed for decision making. We were delayed a little bit just because of delay in the feedback from the professor. So maybe just making faster decisions based off of feedback in a fast environment. Independent research as well. And we'd spoken about um, reaching out to different resources on our own first without having to ask multiple questions of our teammates multiple times. And then going forward, if there's still questions that remain, to then ask for help in that regard. And then finally focusing on the main tasks, which we identified to be the integration for the machine learning model with the application. Action items, how to improve. So spend more time researching topics to meet expectations. Basically, that was regarding different topics of different tasks that we need to integrate into our application project, and just taking the time to research those more so for the next sprint. Also prioritizing the machine learning integration on our weekly group calls, just so we can focus on aligning everybody's ideas in how to make this work, and to also continually continue with the weekly priority tasks that we've been implementing since Sprint 3. Sprint 4 stories planned. We have a couple of items that are in progress and 2 items that haven't been started. So the main focus for Sprint 4 is having the application actually do the sign language translation via the machine learning model. So that's the main goal. One of the side tasks that we are trying to figure out is also to do a recovery of and a reset password system for logging into the application. And 2 of the other tasks that we may have to drop, um, just due to time constraints for the project, would be adjusting sensitivity settings for the machine learning model, as well as getting a history of the translations into a database. That might just not be focused as much, but we're still trying to commit to that during Sprint 4. That may have to be pushed on to a later date. And some of the tasks include um, the database, creating a database of saved phrases in text form, integrating the machine learning model in Android Studio via Java, and figuring out a way to convert an image from the camera to a bitmap to then send over to the machine learning model. And regarding the sensitivity controls, we had an idea of a UI overlay menu where you can just quickly change sensitivity settings for the app. So those are the tasks that we have planned and committed for Sprint 4.
Hi, hello. My name is Rene Diaz. I'm the full stack developer, and I will be introducing a little bit of our app structure. Basically, our app aims to facilitate communication for the hearing impaired community through intuitive features and user friendly design. An overview of our app is that our interface comprises 4 card buttons and an additional button for accessing the camera. Each card button serves a distinct function, enhancing user experience and accessibility. The first one is the Camera Live Feed screen. The Camera Live Feed screen displays real-time translation of hand sign gestures into English. Users can interact with the app by performing sign language gestures, and the app provides instantaneous translations for improved communication. We also had included a guide. The how-to guide section offers valuable tips and resources for effectively using the app. Users can access step-by-step instructions, tutorials, and troubleshooting tips to optimize their experience with the app. The settings screen allows the user to customize their app experience according to their preferences. They can adjust settings such as gesture recognition sensitivity and notification preferences to tailor the app to their needs. Next, we have the app login and sign up page. The registration page screen allows users to create an account with SignIt by providing their email and password. Users can easily register and gain access to sign its features and services. The login screen offers 2 convenience methods for accessing SignIt. Users can log in using their Google account or by entering their email and password directly into the app. This dual login approach ensures flexibility and ease of access for all of the users. As you can see here, you can see the main page, which contains the 4 buttons: the camera, how-to guide, settings, and the logout button. The next screenshot is the login screen, and the other one is the sign up screen. Here is the login database where all of our user data will be stored.
This is the group wiki page through GitHub and the demo. And this is a quick demonstration of the application within Android Studio. Renee is currently signing up for an account. The signup was successful and automatically entered the app. Now he logged out and will be entering his username and password to log into the app in the traditional format. And he was able to sign in successfully.